Okay, 1.2 homework function notation practice. So in number 1, we have if f at x equals 3x minus 1, then find, and then we have a list of things to find, okay? So A wants us to find f at -4. So all we do is every single time we see an x, see this x, we sub in the -4. So 3, -4 minus 1, I get -12 minus 1, I get -13. Okay, I'll do B down here. F at 0 equals 3 times 0 minus 1, which is just -1. Okay, C, F at 3/4 equals 3 times 3/4 minus 1. Okay, with fractions, 3 is actually 3 over 1. We multiply the numerators, which is 9. We multiply the denominators, which is 4. So this is like 9/4 minus 4 over 4, right? Because like 1 is just 4 over 4. I get 5 over 4. Okay, D, I'm going to bust out my calculator. Oh, F at -2.7 equals 3 times -2.7 minus 1. And I get -8.1 minus 1. So I get -9.1. Okay, E is a little bit different. See this -4, how it's out front of the f at x? Essentially, we have like -4, and then we're going to put f at x in this bracket. So we have 3x minus 1. And then what we do is we expand it. So we have -12x plus 4. Okay, number 2, if g at x equals -2x squared plus 3, determine A, g at -4, that's going to be -2. We sub in -4 squared plus 3. I always bracket, like say the -4, because -4 squared is going to be positive 16. Okay, so I get -32 plus 3, I get -29. Okay, B, g at 4, I get -2 times 4 squared plus 3, -2 times 16 plus 3. So -4 squared and 4 squared equal the same thing, so we're actually going to yield the same answer, -29. Okay, C, g at a half equals -2 times a half squared plus 3. So a half squared is just saying 1 times 1, 2 times 2, right? So it's a quarter. And numerators over denominators. So just multiply across. So this is actually like -1/2 plus 3. 3 is actually going to be, if it's over 2, 6 over 2. So I get 5 over 2 for that answer. Okay, D is going to sub in g at x minus 5. So a little bit different because we have to expand the x minus 5 squared, right? So -2. I'm going to write x minus 5 twice because it's squared. And what we have to do is we actually have to FOIL it, okay? Again, don't just square the two terms individually. We have to say x times x, which is x squared, x times -5, which is -5x, x times -5, which is -5x, and then -5, -5, we get positive 25. Okay, expand this -2 into the bracket. I get -2x squared plus 10x plus 10x minus 50, and then plus 3. And then all we have to do at this point is collect like terms. The 10x's are like terms, and the -50 plus 3 are like terms, so it's -47. Okay, E, this is going to come up a lot in advanced functions, but g at -x. So every single time we see an x, we sub in a negative for it. So g at -x equals -2 negative x squared plus 3. So we have to think, what happens when we do negative x times negative x, right? Because we're doing negative x squared. It actually turns into a positive x squared. So it actually yields like the exact same answer. Three, if h of x equals 2x squared minus 3x plus 6, we're going to sub in these values this time, okay? So a is h at negative 4. Okay, so every time we see an x, we have to sub in negative 4. But we see an x 2 times, so we have to sub it in 2 times for this equation. Okay, so we get 2 times 16 minus, well, what's negative 3 times negative 4? Plus 12 plus 6. 2 times 16 is 32, plus 12 plus 6, 32, 44, so 50. Double check. Yep. Okay. Now we go on to B. H at 4x. So this is getting a little bit more spicy here. Okay, so 2 times 4x squared, and remember the 4x is in brackets, minus 3 4x plus 6. Okay, so it's going to be 2 times, well, what's 4x all squared? Okay, just on the side of the paper, it would be 4x times 4x, which is 16x squared. Okay, so 2 times 16x squared. Now what's negative 3 times 4x? Negative 12x plus 6. Okay, now we have 2 times 16x squared, which is 32x squared, minus 12x plus 6, and that's it. Okay, C, h at 1/2, 2 1/2 squared minus 3 1/2 plus 6. Okay, so 1/2 squared, again, is just 1/2 times 1/2. So it's 1 times 1, and then 2 times 2. So 2 times 1/4 minus, and again, numerators multiply, so negative 3 over 2. Denominators multiply. Plus 6. So this is going to be 2 over 4 minus 3 over 2 plus 6. If we wanted to do common denominators, this is 1 over 2 minus 3 over 2 plus 12 over 2. So that's 13 minus 3. I get 10 over 2, which is 5. I should probably just keep going underneath. Okay, D is going to be a little bit longer. Maybe I should start over here. So we have h at x minus 1. So we have to go 2x minus 1 all squared minus 3x minus 1 plus 6. So this x minus 1 squared, I'm going to expand it by doing x minus 1, x minus 1. Okay, now this negative 3 we can distribute right away. Negative 3x plus 3, and then bring down the plus 6. So when we expand these two brackets, we can't just square each term, we have to actually FOIL it. So x times x times negative 1, negative 1 times x, negative 1 times 1. Okay, we can simplify this if you want, plus 9. Okay, now we distribute this 2 into the bracket. So we get 2x squared minus 2x minus 2x plus 2. We bring down the negative 3x, we bring down the 9. Okay, so all we have to do here is collect like terms. We only have one x squared term, so we have 2x squared. We have 3 terms with an x in it, so negative 2, and negative 3. We get negative 7x. And then we have plus 2 plus 9, so plus 11. Okay. And finally, we have E, which is what is h at negative x? So we get 2 negative x squared minus 3 negative x plus 6. Okay, so negative x all squared is x squared. Negative 3 times negative x is positive 3x, and then we bring down the positive 6. So we just get 2x squared plus 3x plus 6. Okay, number 4, if f at x equals 6 minus x squared and h at x equals 3x squared minus 5x, then A, find f at negative 1 plus h at negative 4. So all you want to do is break these down. So let's do f at negative 1 first, which is 6 minus negative 1 squared. So 6 minus, well, negative 1 squared is just 1, so I get 5. Now I do h at negative 4, which is 3 negative 4 squared minus 5 negative 4. So 316 minus, or plus 20, right? Negative 5 times negative 4 is just 20. So I get 48 plus 20, and I get 68. So going back up here, we can just say like, okay, 5 plus 68, I get 73. Okay, so let's try f at 5, and then we'll find h at 2. Okay, f at 5 is 6 minus 5 squared, which is 6 minus 25. I get negative 19. And then h at 2 is 3, 2 squared minus 5, 2. So 3 times 4 minus 10. 12 minus 10, which is 2. Okay, so if we take both of these numbers and we sub in f at 5 is negative 19 minus h at 2 is 2, I get negative 21. Okay, and then C says find x when, so if we actually take a look at this equation here, f at x equals h at x. Okay, f at x, we can just sub in 6 minus x squared. Bring over the equal sign. Now sub in h at x, which is 3x squared minus 5x. Okay? As a recap of grade 10, in order to solve this, we need to bring everything to the right-hand side and set it equal to 0. So we'll have 3x squared, and then we'll have plus x squared, minus 5x minus 6. So simplified, we have 4x squared minus 5x minus 6. Okay, so in order to solve for x, because we have an x squared and an x term, we have to use decomposition. So what two numbers multiply to negative 24? Remember, it's 4 times negative 6, and add to negative 5. So what I do is I just list the factors of 24. 1 times 24, 2 times 12, 3 times 8, we have 4 times 6. Okay, if we take 3 and 8, the difference is that 5. So to add to negative 5, I would need the negative sign on the 8. So I take this middle term, negative 5x, and I rewrite it as plus 3x minus 8x. And we keep the 4x squared and we keep the negative 6. Because there are 4 terms, we need to factor by grouping. Group the first 2 terms, group the last 2 terms. Out of the first 2 terms, we can only common factor out an x. So we have x, 4x plus 3. Okay, out of the second 2 terms, we can factor out a negative 2. So we have negative 2, 4x plus 3. Okay, now we have 2 terms here. What can we factor out of both of these? We have 4x plus 3. Okay, so we have 0 equals x minus 2, 4x plus 3. So in our original question, it says to actually find x. So after factoring, we have to set each of these equal to 0. So if we set the first bracket equal to 0, we bring over the 2, so x equals 2. And if we set the second bracket equal to 0, we bring over the 3, and then we divide out the 4, and we have 2 answers. F at x equals h at x when x equals 2 and x equals negative 3 over 4. All right, D, find x when f at x equals negative 18. So we know x is 6 minus x squared. So we want f at x equals negative 18. And this is D. So essentially what we have is, so f at x, if you actually sub in f at x, we have 6 minus x squared, and then equals negative 18. Let's bring everything to the right-hand side, and I get 0 equals x squared minus 18 minus 6. What if that's negative 24? Just checking. Negative 18 and then 6 minus x squared. Oh, no, that's plus. No, that's minus. Comes over the equal sign. Okay, so I would, you know what, I would do this because we only have like one x term here. I'm going to bring that 24 back over. 24 equals x squared. And I'm going to root both sides. So when we root a number, we actually yield a plus and a minus. So x is going to be plus root 24 minus root 24. And root 24 doesn't actually, it doesn't yield like an integer, so I would just leave it. We're going to get more into that. Okay, so plus 4.9 and minus 4.9 essentially what it is. Okay, now E. Determine f at h at 3. So let's take a look at these actual f at h at 3. I'm going to first solve for h at 3. I'm going to get a number, and then I'm going to solve for f at that number. Okay, so h at 3, 3x squared minus 5x. I'll put it over here. H at 3, 3x squared minus 5x. Double check that that's it. Yeah. Okay. So we have 3 times 9 minus 5, times 3, which is 15. So 27 minus 15, I get 12. Okay. In other words, we can sub in for h at 3, f at 12. Now we're solving for f at 12. So we have f at 12 equals 6 minus x squared. Okay, 6 minus 12 squared. So 6 minus 144. I get negative 138, I believe. Yep. Number 5, determine if the following relation is a function. If it's not a function, explain why. Okay, so as soon as we see that 2 maps onto 1 and 2 maps onto 2, we know that we have the points 2, 1 and 2, 2. In other words, on a graph, it would be 2 and 1, and it would be 2 and 2. So this would fail the vertical line test. Okay. Also, 14 maps onto 2 different numbers as well. So not a function. And you don't want to just say that it fails the vertical line test because you're not given a graph, but we can say because 2 maps onto more than 1y. Or you could have said 14 as well. Okay, and number 6, just as a practice, write the ordered pairs in each mapping diagram. So this is negative 1, negative 3. Just follow the arrows. 1, negative 3. 1, 0. 3, 2. 5, 2. Okay, and then the next one, -4, 1, -2, 1, +2, 1, and 5, 6.